Problem 10.4, it states that suppose v is equal to 0, this is v is equal to 0 and a which is equal to a naught sine of kx minus omega t and the y direction, where a naught, omega and k are constants. Find electric and magnetic field. Find electric and magnetic fields and then check that they satisfy the Maxwell's equation and vacuum. This problem states that we have given V and A and we have to find out electric field and magnetic field, and then after this we use electric and magnetic field and Maxwell equation and find out that these electric and magnetic fields satisfy the Maxwell equation or not. So let's start. The first thing is to find the electric field. We may have del V minus partial A divided by partial T. So V is equal to 0 minus partial divided by partial T and A naught sine kx minus omega t in the y direction. Then this electric field must have sine to cosine and this angle. So let's see, cosine kx a naught cosine kx minus omega t y, and we have the differentiation of this with respect to t, then we can get omega, and electric field will be equal to minus plus a naught omega cosine of kx minus omega t and y. So this is the electric field. Where the magnetic field can be found out del cross A, which is equal to x, y, z. So partial divided by partial x, partial divided by partial y, partial divided by partial z, and the values of this is a y, so 0 the x and this will be equal to 0, and only y component here, a naught sine kx minus omega t. After simplification, you can do this very easily. So we can find out here a naught k and cosine of kx minus omega t, which is y cross x. It means that it is in a z direction. So we have the electric and magnetic fields now. Here we have the electric field and magnetic field that we have find out, and now we want to check the Maxwell's equation. So the first Maxwell equation we know, del dot divergence of E, which is equal to in this free space. We are looking this in the free space. This is the condition. So divergence of this will be equal to 0. Now the divergence of E, which is equal to divergence of electric field a naught omega cosine of kx minus omega t in the y direction. So the divergence of this, if I write down this in its components, partial divided by partial y, partial divided by partial z, and divergence of this omega cosine of kx minus omega t and y. Now, partial divided by partial x. This is okay, but there is no any component of x. So this one and this is y dot y, this is equal to 1, but this is differentiation with respect to y, so there is no any component of y, so it means that the divergence of this is equal to 0. It means that the first Maxwell equation is satisfied. The second Maxwell equation, del cross b, which is equal to 0, this is also very simple. Divergence of b, partial divided by partial x, partial divided by partial y, partial divided by partial z, and divergence of b, a naught k cos of kx minus omega t, and this is in the z direction. Okay. So z dot z, this is equal to 1, but this partial divided by partial z, there is no any component because this is not depend upon z, so it means that this is equal to 0, and the second Maxwell equation is also satisfied. The third Maxwell equation, del cross E, which is equal to minus partial B divided by partial T. So first of all, the left hand side, del cross E, which is equal to x, y, z, partial divided by partial x, y, and z. And here we have only the electric field and the y component. So a naught omega cosine of kx minus omega t, and z is equal to 0. And from this, if we find out the curl of this, then this will be equal to this is equal to 0. And if we consider y, so this and this, this is also equal to 0. In the z direction, yes, in the z direction we can have this minus this. So it is clear, this minus this. So we have partial divided by partial x, a naught omega cosine of kx minus omega t. And here this becomes minus a naught omega, and this sine kx minus omega t, and with respect to we have k. So it means that from this minus a naught k omega sine of kx minus omega t. So this is the left hand side, and now the right hand side is this partial b divided by partial t. Then we have partial bv a naught k cosine of kx minus omega t. So differentiate this with respect to this one. So we have minus a naught k sine of kx minus omega t, and differentiate with this minus omega, and we have plus a naught k and sine of kx, and this is omega minus omega t. So the left hand side, which is equal to the right hand side, because we have here minus, so minus is coming from this. So it means that this is also satisfied. The Maxwell fourth equation, del cross B, which is equal to mu naught epsilon naught partial E divided by partial T, because there is no mu naught J, because we are working here in a free space, so mu naught J is missing here. First of all, let's consider the del cross B, and from this del cross B, we can easily use the determinant and find out del cross B, and I have the value a naught k square sine of k x minus omega t and the y component. So you can do this very easily because you have a determinant x, y and z, partial divided by partial x, y and z, and we have this term in the y here, a naught k square sine of k x minus omega t. So you can do this very easily. You can get this del cross B, which is equal to this thing. And okay, now consider the left hand side. In the left hand side, I can consider partial divided by partial, this one, partial E divided by partial t here. So differentiate this with respect to t, then we can have, if I write down this directly, because this is with respect to t, we have minus sign, and minus sign is here, then it's plus, and this convert to the sine, and a naught omega square sine of kx minus omega t and in the y component. Now putting these values in this equation, del cross B, we have a naught k square sine of kx minus omega t y, and the right hand side mu naught epsilon naught, and partial E divided by partial t, a naught omega square sine of kx minus omega t in the y direction. So it is clear that this and this term can be cancelled out, and we have a naught k square, this term, which is equal to mu naught epsilon naught a naught omega square. So a naught will also be cancelled out, and we can have only k square, which is equal to mu naught epsilon naught omega square. And we know that omega is equal to ck, and k, which is equal to omega divided by c. We know about this. This is the relation between wave vector, wave number, and frequency. So k omega square divided by c square, which is equal to mu naught epsilon naught. Mu naught epsilon naught, let's see, I will write down this later. So mu naught epsilon naught omega square. So this omega square will cancel with this omega square, and this is equal to 1 over c square, which is equal to mu naught epsilon naught. But we know about c square, and c square here, this 1 over c square, which is equal to mu naught epsilon naught. C square is equal to 1 over mu naught epsilon naught. So mu naught epsilon naught. So it mu naught epsilon naught, which is equal to mu naught epsilon naught. So this cancel out. So the left hand side, which is equal to the right hand side. So this is also satisfied.